All right, so I can use my calculator. That factorial symbol works nicely, because otherwise if you have 20 factorial, you're going to multiply from 20 down to 1. So we can go and we can put in our 3, and then you want to go to math. Math. It's the third button down on the left. And once you're in math, it gives you the options at the top, and we want to go over to our probability options. And mine's number 4 for the factorial symbol. Did everyone find the factorial symbol? No, you should just be able to hit math. And then once you get it, you just hit enter and it's going to put it next to your number. So if I wanted to calculate the 3 factorial for me, it'll do that. And it'll say, okay, there it's 6. So I can have it do some of the work for me and kind of type that in if I want. Did everyone find factorial? All right. So that's an option. That's not the option I really want us to use, but we can. We're going to go to our new favorite spot on the calculator, which is you have to hit the second button and go to VARs, which is over by the arrow. The PDF stands for probability distribution function. CDF stands for cumulative distribution function. What does cumulative usually mean? Adding things up. So it's for when you're looking for more things than just one amount. If you want to have 2 or more, or 3 or more, something like that, then we'll use that one. So for our particular case, we want to use this Binom PDF. And yours may or may not look like mine. If it doesn't, I'll write it out. So trials, it wants to know what's your N. For us, we had a 3. Your P is your probability, so 0.5. And X is the number that you're interested in. That's our 2. And then I'm just going to hit enter. It's going to bring it up in parentheses. If yours just popped up, Binom CDF, this is how you should enter it. You should enter the 3, put a comma, then put your 0.5, put a comma, and then put your 2 for your X, and then close it out. So we separate everything with our commas. And then I just enter again. And we get the same thing. Questions on that? Did it work? No? 2.25 is after we read, because that's the first thing. If we don't read, we're not getting anywhere. The second thing we should do is identify what we have. So it's from here on out going to become very important to identify the given information so we know what we have. So a survey found that 1 out of 5 Americans say he or she has visited a doctor in any given month. If 10 people are selected at random, find the probability exactly 3 will have visited a doctor last month. So we read it. Now what can we identify? And remember, for a binomial, I should be able to find an N, a P, and an X. Can we identify any of those? N equals 10. X is 3, and I heard 1 out of 5 for P, which is good. Then I can calculate what Q is. So Q is 1 minus P, so 1 minus 1/5, so 4/5. And what are both of these as decimals? 1/5 becomes 0.3. And 4/5 is so 1/5 is 0.2. If 4/5 is 0.8, they should add up to 1. All right. So now that I have my N, P, X, and Q, I can go ahead and put it in the formula. If you're using your calculator, you only need these, because it doesn't ask you about Q. It's going to work with Q on its own. So I'm going to set it up both ways. Still PDF because we're looking at an exactly 3. So it would be a binom PDF where I've got 10 as my sample size, 0.2 as my P, and 3 for my X. If I want to plug it in and I want to say the probability of getting 3, I've got 10 factorial over 10 minus 3 factorial times 3 factorial, then 0.2 raised to the third, and 0.8 raised to the 10 minus 3, so raised to the 7. And we should be able to work both of these out and get to a similar point. So let's see where we get to. Due to my rounding and different things, when I did it by hand, I got 0.201. What do you get on the calculator? Same thing. That might not always happen. Does anyone need to see the calculator? Does anyone need help? Yeah. So we're going to go back to second var. So we get into the distribution. Then I want to scroll down till I get to A, or at least it's A on mine, wherever it says binomial PDF. And then I need to tell it that I have 10 trials, 0.2 for my P, and I'm looking at exactly 3 of them. Does your screen match mine? Okay, so then yours wants you to put it in parentheses with commas separating them. So you'll do 10 and then a comma. All right, and then if I hit calculate, I should get back to the same thing. And it depends on where you round as to whether that always happens or not. But it should be pretty close again. So once I figure out my probability, the most important thing that I want after that is my sentence. So the probability, bless you, of exactly 3 people visiting the doctor last month is 20.1%. Questions on that? All right, let's look at what happens when it's not an exact amount. So, the survey from Teenage Research Unlimited found that 30% of teenage consumers receive their spending money from part-time jobs. If 5 teenagers selected at random, find the probability that at least 3 of them will have a part-time job. All right, so I need to identify. What can I identify? 5 teenagers, so that's my N. What's P? 0.3 from the 30%. And X says that it should be at least 3. So greater than or equal to 3. What would Q be? 0.7. So 1 minus 0.3 gets me to 0.7. And then this is where I want to use my other one. And I'll go over by hand in just a minute. But for the calculator, we want to add up an amount, right? We want to add up the total. Now, just because our calculator isn't quite smart enough, it's pretty smart, but it's not totally smart. We have to do 1 minus my binom CDF. Because your calculator can only find from a number down. It can't do from a number up. So we're going to find the complement. The binom CDF is going to find from 0 up to 3. And then we're going to do 1 minus that to get the amount we're actually interested in. So that means I still have 5 trials. And my P is still 0.3. But if I want 3 to be included in my probability, I need to find the probability from 2 down. So we're going to put a 2 in because this portion is finding x less than or equal to 2, which is the amount we don't want to know about. We want to know about 3 or more. So we have to take 1 away. And then when we subtract, we do 1 minus it, it's going to give me the probability that I'm interested in. So let's see what we get. We're going to get 1 minus. This time we're going to go use our binom CDF. It asks for all the same things. So we had 5 teenagers, and we had 0.3, and then we had a 2, because we're putting in the opposite amount. Or you're going to put them in with commas in between. That's going to give me 0.83692. I'll just take them all. You can definitely do that as well. I'm just showing it out by with the 1 there. So then if I subtract that from 1, did I get the right number? Yeah. All right. So 1 minus my 0.83692 tells me that the probability I'm interested in is 0.16308. And you can absolutely have it do it right away by saying 1 minus, then going to your binom CDF. And then if you hit calculate, oops, what I hit? That's not calculate. But then it'll do it for you. So you have the option to put the 1 minus before you go find the binom CDF. And then it'll be the correct answer right away. Either way you want to do it. Did everyone get that? That answer? Yeah? For a cumulative amount. So finding something that's not an exact amount. And, yeah? Yes. So then if I want to use the formula, I still want to find the complement. Because think about it. If I try to find, well, actually, it doesn't matter as much this way. But I would have to find the probability when there's 3, 4, and 5. But I could do the opposite amount and find a few less of them in terms of that. Especially if we had a sample size of, say, 10. And I wanted 3 or more, I'd have to find all the way from 3 to 10, and I don't want to use the formula 7 times. So we always try to use the opposite amount. So we're going to find 1 minus again, and I have to use that formula for all the other options, which I have 5 factorial, and then we would get 5 minus 0, because that's an option. You could have none of them. And then times 0 factorial, which is, what does 0 factorial equal? 1. And then you would do your 0.3 raised to the 0 and 0.7 raised to the 5. That's just the first option. Then we've got 5 factorial over 5 minus 1 factorial and times 1 factorial. Then we'll do 0.3 to the first power